All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course and we're still doing our learning module. Let's have a look at what we went over tonight. Now, last night, if you recall, I don't know if I got around to explaining to you, but the last thing I went over was the E greedy algorithm, this here. And tonight we're going to pick up where we left off. So every time we're faced with the ability to take an action, sometimes we're going to choose the best move, sometimes we're just going to choose a random move. This type of algorithm can be quite powerful in a reinforcement learning context by not always just choosing the best possible move right now, but sometimes, especially earlier on, allowing ourselves to make random moves that allow us to explore various different possible states and actions more. And maybe over time, we might decrease our value of epsilon more often, choosing the best move after after we're more confident we've explored what all of the possibilities actually are. So we can put this into practice. And one very common application of reinforcement learning is in game play. If we want to teach an agent how to play a game, we just let the agent play the game a whole bunch, and then the reward signal happens at the end of the game. When the game is over, if our AI won the game, it gets a reward of one, for example. And if it lost the game, it gets rewarded -1. And from that, it begins to learn what actions are good and what actions are bad. We don't have to tell the AI what's good or what's bad. But the AI figures it out based on their reward. Winning the game is some signal, losing the game is some signal. And based on all of that, it begins to figure out what decisions it should actually make. One very simple game, which we may have played before, is called NIM. And in the game of NIM, we have a whole bunch of objects and a whole bunch of different piles. Each pile is an individual row. So it would look something like this. This is our game of NIM setup here. So you have 1, 3, 5, and 7. These are all 4 rows. And these are each objects, or this is each object in each row. You have 1 object, 3 objects, 5 objects, 7 objects. And the game of NIM is a two-player game where players take turns removing objects from the piles. And the rule is that on any given turn, we are allowed to remove as many objects as we want from any one of the piles. We have to remove at least one object, but we can remove as many as we want from exactly one of the piles. And whoever removes the last object loses. So player one might remove 4 from the four from the last pile. Sorry, row or pile counts as the same thing. These are all rows in our piles. So player one might remove 4 from the last pile. As you can see here, we started out with 7 in this row, and player 1 removed 4, so now we have 3. Player 2 might remove 4 from the third pile or row. You can see that here. We started out with 5. Player 2 removed 4, so now we have 1. Next, player 1 might remove the entire second row. So you can see we had 3 here in our second row, and player 1 removed the whole row. Player 2, if they're being strategic, might remove 2 from the last row or pile. Where did I go there? Okay, yeah, I don't know why my mouse is acting crazy. I'm gonna pad. Okay, and this is that here. So you can see we had 3 left from the first time we got our objects removed, and then player 2 strategically removed 2 of them, leaving 1. Now we have 3 rows piles left, each with 1 object left. You can see here 3 rows or piles left, each with 1 object. Now player 1 might remove 1 from 1 pile. This will be our new board game here. Player 2 removes 1 from another pile. This will be our new board game here. So inevitably, and now player 1 is going to be left with choosing the last object from the last pile, at which point player 1 loses the game. And this is our board game here. No more objects to be removed, no more piles. Fairly simple game. Piles of objects. Any turn we choose how many objects to remove from one pile, whoever removes the last object loses. And this is the type of game we can encode into an AI fairly easily because the states are really just 4 numbers. Every state is just how many objects in each of the 4 piles. And the actions are things like how many things are we going to remove from each of the individual piles. And the reward happens at the end. That if we are the player that has to remove the last object, then we get some sort of punishment. But if we are not, and the other player had to remove the last object, then we get some sort of reward. So we can actually try to show a demonstration of this. Now, I was going to actually code the demonstration tonight, but I didn't have the input that I needed at first. I didn't know. So you can see here, this is the input that we needed, and I actually just downloaded the input, but I don't actually redo everything because it is going to make a much longer video. I'm not even sure this one is going to make the cut. It might be too long. We'll see after I'm finished recording it, but we'll pick it back up tomorrow. And of course, I'll keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.